discussion about, who actually can generate the keys and who actually, can decrypt the keys or encrypt the keys, etc. And it was decided pretty early on that no one entity would alone be able to do that, and that it would have to involve a conspiracy of a large number of people in order to do that. And the key signing ceremony, I think, was pretty elaborate, and there were a number of people there for that. And there does have to be a certain number of people involved in order to actually produce those keys. So I think in general it was a good, well thought through plan in that no one entity would be able to control the whole thing from start to finish.
So there's an interesting reason why a lot of authentication systems fail. Anyone here familiar with the phrase federation in the technological sense? So the whole thing is if you want everything to work, you need a single root. I'm just going to say that as an absolute statement because we've seen 10 years of people arguing otherwise and failing miserably. So you need like one single source that everyone trusts. The problem is anyone who normally becomes that single source turns into a monster. This has happened time and time again, and believe me, there's industry after industry where I can show you it being true. They're like, look at all this power, I can make a ton of money.
But not in the DNS system, that's never happened.
And the interesting thing about the DNS architecture is it has a property of what we're referring to as a silent overseer. Structurally, there is a single root, but that root is so constrained both by the technology, which is the best delegation system that we have out there, and by enormous amount of politics and political checks and balances. And some people think it's a bug. It is a feature. It is because of this ability to have a root that everyone can trust, but it itself is constrained, that we're able to build out these systems and actually have a very strong neutrality in how the system is operated. And so this splitting up of 7 keys, it's less about, and I'm one of the people who has one of the keys, by the way, it's less about a power that I have and more about a power that they don't. It's so the only way where that key material could be abused is if all of us came together in some kind of crazy international conspiracy. That's not happening.
Thank you. Before moving to the other question, I would like to add some...
Okay, Dan.
It's very hard. So I want to add that there were actually 21 trusted community representatives who took place in this key ceremonies. I was the ceremony administrator on behalf of ICANN, and there were 18 countries represented in those events. So it wasn't only US based, it was people from China, Czech Republic. I don't remember exactly where everybody was from, but there was a lot of countries, 18 countries represented. So one more thing I would like to remind, I believe most of you read a lot of news this week about a reboot key being available and all. There's no reboot key. I want to assure you that there's no such thing that I'm aware of. So what people were trying to talk about was the RKSH, basically what Dr. Lamb just explained. Next question.
Dan, you said that today we can use DNSSec to distribute self-signed SSL, or at least authenticate self-signed SSL certificates and PGP keys. Did I hear that right?
Yes.
And so I guess I was a little asleep on the ball the last couple of years looking at this. Can you just talk briefly about any new RR types or how that's done?
So the fundamentally interesting question is DNSSec allows you to release bootstrapping information. And normally, this just comes from DNS. You want to connect to an IP address, you don't know what it is, you can bootstrap and find out what that IP is going to be. DNSSec upgrades us from finding out IP to finding out other stuff, certificate records, anti-spam records, and so on. The precise question you're asking is, so what does it actually look like on the wire? What are the actual formats? That is a raging debate, which I'm not getting myself particularly into. So what the piece that I've worked on, the piece that we're actually releasing code for, is we've got deliberately incorrect representations of the information. So we'll have, this is a very rough way of saying, oh, you want the SSL certificate? Here's kind of what it looks like. This is the wrong way to do it, but it's okay. We're showing it's possible to get end-to-end trust of small bits of key information delivered from the delegated DNS into your desktop so that it can know whether to take trusted paths or not.
So if I wanted to get in on the debate on this standard, now is a good time since it's not set.
Now is a good time.
That would be the time.
Yes.
Thank you. Any question?
Yeah, I was interested in the registration issue. I mean, when we come into basically any certificate or any signing scheme, you're really only as strong as your weakest link, and you have a lot of registrars out there. Can you talk about, and I've worked with a lot of the registrars, and quite frankly, a lot of them are really stupid. I mean, phenomenally stupid. I had a tech support call, seriously, I had a tech support call a couple months ago where I talked a guy into, with root privileges, one of your domain registrars, we'll leave the name out of it to prevent a lawsuit, but basically where I talked a guy with root privileges into running a command. He had no idea what he was doing, running a chown -r command for him with root privileges on a box. So I have to assume that the same kind of, and this isn't even social engineering, I just called up and told him, hey, I've got an account, I need you to do this for me. And he said, okay, sure, no problem. And hey, what did that do again? So I guess my question really comes down to what protections are we putting in place to prevent the dumb registrar out there from starting to sign, starting to sign some of these certificates? Because I think at that point, I know we can talk about revocation, but I don't think that's. I mean, it is practical if we find out that they're signing bad certificates. But if they have bad practices in the first place, I think the model starts to fall apart. So somebody talked about the protections put in place or the verification of the registrars.
Yeah. So I'll start with that. Dan may have something to add to that. Rick does as well, but so I agree with what you said with respect to, there is a large number of registrars out there. Some are better than others. The opposite extreme of that is that there are some very, very, very good ones. As a matter of fact, probably the most well-known of them are very good and have good security practices. The registration process, unfortunately, from a business model perspective, often tends to lean towards ease of registration more than anything else. So it's about volume more than it is about quality, if you will, for particularly some of the smaller ones. Now, that doesn't mean that they deliberately don't want to have good security. It just means that, in order to be competitive, it's all about, one-click sign up and moving through and adding things. As with any system, and the same applies to digital certificates as well, that there are some CAs that are better than others, and some that do very rigorous checks and some that don't. And so I think we're going to wind up in the same sort of dilemma when it comes to signed delegations, and that's going to be how good is the registrar behind that. And I think over time the reputations of the registration system will begin to come into play and become more important. Where today, literally everything is self-signed, if you will, once you get beyond, COM, let's say, or EDU or any of the other assigned top-level domains, although COM is not just yet. But then everything's pretty much self-signed, and there's the trust system is that I trust you as a brand or I trust you as a business, and so therefore I'll trust your signature. But ultimately, it may become more and more important who additionally signed that than just the fact that you signed it.
So this kind of blew my mind. There is a fundamental structural reason why DNSSec ends up having better properties with bad web. DNSSec can deal with bad web interfaces far better than X509 can. If you have the best CA in the world and they issue you a certificate, Lend Certificate Shack down the street can also issue someone else's certificate, and their cert is just as good as your cert, even though you spent all that time, money, and energy getting the really good and strongly validated certificate. This means, unfortunately, X509 as a structure ends up being a race to the bottom. When certificates first came on the scene, everyone did strong validation, and then one guy did it a little weaker, and the next guy did it a little weaker, and the next guy did it a little weaker, and it went down pretty far. And that's just something that has to happen when everyone is able to operate in the exact same space at the same time. What's interesting about DNS, and this is fascinating because you know it was not intentional, but what's fascinating about DNS is you have this entire network of registrars, and they handle the web interface, they handle the SQL code, they handle all the stuff that has empirically in the field been what's been getting attacked. Honestly, way more than cache poisoning has been. If you have one company like a Mark Monitor or a CSC or something, and they are your registrar, these guys are massively professional operations, and they watch out for what's going on. Importantly, as long as your name is registered through a particular registrar, no other registrar can impact your name. They just don't have the ability because the actual registry, the VeriSign.com, only accepts updates from the one trusted registrar. So because you have what we call the exclusionary property, you have 1,000 registrars, this one's a little more secure, this one's a little more secure, this one's a little more secure. It becomes a race to the top. That is how you structurally create a secure system.
Thanks.
Which is not, I believe, only going to make sure that the users are getting the best value, but also at the same time the best service.
We want to be able to reward the registrars that do the work that protects users, and that is fantastic.
Yep. Next question.
Building on your on the exclusive property, you talked about this a bit at your Black Hat talk, Dan. If you go one level higher in the stack, it's sort of not the one machine trusting another machine, you got the name in there correctly, there's no questions, but was it a person looking at that from address in an email, looking at a website URL, not one of us, one of those other people, there's a lot of attacks. I'd say if you look at technologies like SPF, the reason why SPF doesn't block all spam is not due to rampant DNS cache poisoning. It's because people say, oh, bank-secure.com, I go to the bank, so that must be my bank. Are there specific, I think, we talk about EV certs, brand protection companies sort of going out, taking out these sites. Are there specific proposals, are there specific standards for getting EV cert technology into DNSSec? Are there ways you can do this in a really secure way where it's not just going to be more whack-a-mole going out looking for all these cousin domains, IDN name spoofing, all of that kind of stuff?
So a lot of people think now with DNSSec we don't need the certificate authorities, and it's not true. DNSSec protects domains. The certificate authorities identify brands. Domains and brands are not the same thing. With DNSSec, we can say the only certificate in the world that is valid for this domain is the one with this particular hash. Now, if it turns out that that particular certificate is an EV certificate, what we now have is a combination of two good things. We have extended validation identifying the brand of the website, and we have DNSSec making sure no other CA, no other certificate, no other code can actually interfere with that one extended validation cert. Last year, Mike Sussman and Alexander Sotorov actually demonstrated tremendous attacks against extended validation sites if you could do something as simple as getting a non-extended validation certificate for the same name. DNSSec stops that. Extended validation is interesting technology. Right now it's in the browser. Eventually we want to see it in email as well. Why shouldn't you be able to know from an extended validation standpoint that you got an email from your bank?
Yeah, I think what's incumbent upon the people in the industry that sort of create the processes and create the security mechanisms, no matter what part of the infrastructure it is, I think we have to realize that if it's too hard for most people to implement, they will find an easier way or something easier to implement that is less secure. It is our responsibility to come up with good security that's easy to implement. And I think Dan demonstrated some of that a couple of days ago at his talk at Black Hat, where all of the talk was about, including from me, by the way, was about DNSSec is hard. It's going to be really hard to implement without the right tools to make it seamless and easy for the end user, and that the feedback is good. because I can tell you that if the end user has to go look up which registrar registered this name and all this, it's never going to happen. It's never going to